Hi, my name is Pfeiffer, and I'll introduce you to our work on the prediction of pedestrian trajectories using LSTM neural networks. For robot motion planning in dynamic environments, accurate and interaction-aware motion predictions for other agents surrounding the robot are required. Our approach combines a high prediction performance, and therefore low prediction error, with a low computational effort such that it can easily be deployed on a mobile platform with limited computing power. The motion and interaction model takes into account three sources of information for each pedestrian: its current velocity, its static environment, and the other pedestrians in its vicinity. Each channel of information is first processed independently before being fused to forecast the future velocities of the pedestrian of choice. As our approach does not only take into account pedestrian interactions among each other, but also with the static environment, a proper understanding of the static obstacles surrounding each pedestrian needs to be given. To reduce the overall training complexity and to find a meaningful, compressed representation of the occupancy grid, we pre-train the feature extraction on the static occupancy grid using convolutional autoencoders. Additionally, we introduce a new representation for the pedestrians in the vicinity called the angular pedestrian grid. Each cone of this angular pedestrian grid contains the distance to the closest pedestrian within the angular range of each cone, or the maximum range if no pedestrian is present. For training and evaluation, we use a simulation and real-world pedestrian trajectories. At every time step, in this case for the agent with ID 3, the velocity, the static grid, and the angular pedestrian grid in the local frame are fed to the model in order to obtain a predicted trajectory for the next 3 seconds. One evaluation on a standard CPU takes only around 3 milliseconds per pedestrian, which makes the approach applicable to high pedestrian densities. Thank you for your attention, and I'm looking forward to interesting discussions during the interactive session.